So I'm going to start here. So first of all, I'm going to explain you how the process of a structural designing works. Okay. So I'm going to open the whiteboard here to explain you. So this is the real practice which we do in our consultancy. So SpanX Structure is a structural consultancy where we provide the structural drawings and all. So we design and analyze the structures here. Okay. So the same process how we follow in our consultancy, we are going to explain you here. Okay, everyone. So
Yeah.
first of all, what is happening in our consultancy? We get architectural plan. So this is the first thing which we receive from the client. That is architectural plan. So this architectural plan which you're receiving from your client, it may be one architecture or even someone who's willing to build the structures may also be your client. Okay, so your client may be the architecture or someone who's willing to build the structures. He and she can also be the client. Okay. So you will first of all get the architectural plan, and after getting the architectural plan, your work start from there. Okay, so how the architectural plan looks, I'm going to show you. So I think you already actually have seen, if you're working in the consultancy or if you're working as a site engineer also, you might also seen that how the architectural plan looks. So just I'm going to show you this architectural plan. So can you see this, everyone?
Yes, sir. Yes, sir.
Yeah, my screen is visible to everyone. Yes. So this is the typical floor plan, and this is the ground floor, and this is the basement layer. So this is the parking layout you are getting here. Okay. So along with the plan, you will get an elevation also. So can you see the elevations and sections here?
Yes, sir.
Okay. So like that, you will get a architectural plan with the longitudinal sections and elevations also. So this is a typical floor plan. And also there are a lot of towers here, like tower 3, 4, 5, 6, 7, 1, 2, and like that we are getting a towers here. And you can just see that we have a ground floor also, which we will call it as a podium level. And again, we have a silt floor, which is a parking layout here. Okay, so like that, you will get a architectural plan. And this architectural plan has to be get converted into a structural framing plan. Okay. So the first thing which you will get it from architecture is this. And here what you have to do, you have to read the plan here very well. So you cannot directly start building your structural framing plan. You have to read the plan very well here. You have to look at the elevations, you have to look at the sections, you have to look at that how you're going to give the columns and all like that. You have to little thing you have to look at your architectural plan. Means to say that you have to completely read the architectural plan, sections and elevation here. Okay, so you will get a level also like 94.6, 95.86, 95.35. These are the levels. Okay, so like that you will get it architectural plan, and next work will start from there. Now I told you that after getting the architectural plan, next you have to convert this architectural plan into a structural framing plan. Okay, so the structural framing plan will be the combination of columns plus beam plus shear wall. Okay, so in this only you will be placing your columns, beam and the shear wall in the structural framing plan. So how the structural framing plan looks, I'm going to show you. So can you see this, everyone? So this is the column here, you can just see, and this is the shear wall placement, and these all the beams are there. So in the structural framing plan, you will be getting column, beam and the shear wall. So everyone is okay with that?
Yes, sir.
What actually the structural framing plan consists of? Okay, so coming to the next, that is very important, making the DVR. So can anyone tell me that what actually DVR is?
Design basis report?
Yeah, actually this is a design basis report. Very good. So this is a design basis report, right? So what actually design basis report is? whenever you're making a structural work, you have to make first of all the report there. Like what is your basis of design? So in this design report, you have to mention that what actually the zone factor you are having, what is the wind speed. So like that little, what is the soil report and all, like that little informations about the structures has to be get mentioned in the DVR report. So this is the first thing you have to create before making the model in the ETABS. That is a design basis report, because through this design basis report only you're going to model in ETABS. Okay, so DVR is your design basis report. So this is the basis of the report you are going to make it, and you have, according to this DVR, you have to make the mathematical model. So everyone is okay with this DVR? This is the documentation which you have to make it before making any mathematical model.
Yes, sir.
Okay, so in this DVR, you have to mention everything, like earthquake zone factor, what actually it is, what is the wind speed, what is the grade of material you're going to use it, like little informations about your structures has to be get mentioned in the DVR. Where this location, where is the project locations is located. Okay, what is the previous earthquake report about that location, soil report and all has to get mentioned in the DVR. Okay.
Hello.
Yeah.
Yes,
Yeah. Anyone is asking questions from me?
hello.
Yeah. Hello.
Hello.
Yeah. Hello. Yeah. Hello. Yeah.
Am I audible?
Yeah. You're audible to you. Yes.
Yes, sir. Yes, sir. I have a question about
Yeah.
who will convert the architectural plan in the structural framing
Yeah.
plan?
This is done by the structural engineer only. Yeah, you maybe have keep the
Okay.
draftman and all, so maybe draftman will help you in doing that. Lekin first of all,
Okay.
you have to instruct him that how you have to create it.
Right.
Okay.
What
So
arrangement we need for that?
Yes. Draftman will be
Right.
there, but you have to train the draftman that how you have to make this framing and all. You cannot directly tell draftman, okay, make the structure framing like that. You have to train him that how to place the columns, what is the orientations of the columns could be placed at the first time. Okay, where like little information you have to give the draftman, and according to that draftman will make the structure framing plan. Okay.
Right.
Yes. So the next is you're making the mathematical model in ETABS. Okay, now the mathematical model will be made. And before that, there is different way of making the mathematical model. So what are the steps actually? What are the different way to make a mathematical model? I'm going to explain you. So mathematical model means to say there ETABS model. Directly I can say that mathematical model is ETABS model. Okay. So why I'm using the word is mathematical? Because the model which we are making in ETABS contains some mathematical values. Let me open. Okay, later on I will open the ETABS software. First of all, understand that why I'm calling this as a mathematical model, because it will contain some values. If I'm drawing the beams, if I'm drawing the columns, it will have some mathematical values. Like column will have axial forces, bending moment in both of the direction. The beam will have moment, shears, torsions. So the value which is in the form of bending moment and all, it has some mathematical values, right? Okay.
Right, sir.
So what are the different steps can we adopted here to create a mathematical model? How you can create it? The first very common step is you can create through the grid lines. Okay. So you can create a grid line in ETABS, and you can create the mathematical model through the grid line. So might you have seen the grid lines like this, right? Everyone? This is grid line, you have to place the column like this. And through that, you can make the mathematical model. So this is, we can say, an easier step that is not very complicated step. You can easily create a mathematical model through this grid line step. Second way of creating the mathematical model, you can keep it like .dxf floor plan. So through this step also, you can create the mathematical model, that is importing .dxf floor plan in your ETABS. So what actually it is, I'm going to explain that. Let's suppose that you have created a structure framing here, everyone please see here. Let's suppose that we have created a structure framing this, and in this structure framing, I have to convert it into center line plan here. So right now, which you're looking here, this is a center line plan. So this structure framing has to be get converted into center line. Okay, so this is which you're looking, this is the center line here, and this is the beam center line. Okay, so please remember that whenever you try to convert the structure framing plan into center line, don't take the column center line, take the beam center line. And this is because I will explain you further in the class that why we're taking the beam center line not as a column center line. Okay, and please remember this we are doing only for creating the mathematical model in ETABS. Okay, any doubt to any doubt? Hello?
Sir?
Yeah, any doubt up to
No,
here?
sir.
No.
No, sir.
Okay, so can I proceed further? Yeah. So third is you can create the mathematical model through Revit software also. Revit structure software. So have you heard this name before, Revit structure, right? Before?
Yes, sir. Yes,
Okay.
yes.
So through this Revit structure, you can create the mathematical model. Now you will be telling that, okay, how we can create any mathematical model in ETABS through the Revit software? Yes, this is possible because the Revit software has developed one extension called as CSI Revit.
Okay.
So yeah, so through this software, this is extension, this is not a software. Through this extension, we can create a whole model in the Revit software, and we can import that model into the ETABS software through this extension file. As you know that ETABS is not a modeling software, it is a analyze and design software. So that modeling becomes very complicated in ETABS software. So we are taking in the help of Revit software as a modeling, and the further analysis and design will be performed in ETABS only. Okay, so this is the way where the very complicated model will come up with you. Like if you have a curve where you have untypical floor plans, very irregular structures. So in which very irregular structure will come, in that case, you have to take the help of the Revit structure software. Okay.
Yes.
So I'm going to show you some complications of the software, complication of the model, so that you will understand better. So let me open first of all ETABS, okay, where I will show you that in which case you may require the Revit structure software for modeling structures, because in your when you're doing the structures in that many complicated model will come with you. Okay, and in that ETABS will not be enough for modeling that. I'm going to show you some with some example here. What actually I mean to say. Everyone can see this software. Sorry, everyone is able to view this my ETABS software.
Yes, sir.
Yes.
Okay, so can you see the complications here?
No.
Can you see this curve? So this is only possible when you will having any modeling software like Revit. Okay. Are you getting everyone? Please.
Yes, yes, sir.
Yes, yes, okay.
Okay. So this is very complicated soft modeling, and you cannot do this directly in ETABS. You have to take the help of the Revit structures for modeling this all the complexity, and later on you can transfer this to the ETABS. Okay. Now come back to the here. So I already explained you that through the Revit structures, you can import the file and further you can do the analysis. .dxa floor plan we have, grid lines we have. We can also import IFC files. So this is one type of the file where you can import it in ETABS. So this IFC file you may find in the StatPro, you may find in the Tekla, Revit, and also many of the software actually can able to export the IFC file, and you can import that IFC file in ETABS. like we have a SAP 2000. So SAP 2000 can able to export the IFC file, and you can import this IFC file in ETABS and do the further analysis. Okay.
Yes.
So like that, few more things like that. Even you can import your directly your architectural plan also. So through that also you can directly start modeling the ETABS in ETABS. Okay. So basically, if you look at now, if you're having 100 projects, in that 80 of the projects you will be doing through .dxa floor plan. So this is a very common way of doing the structure modeling, importing .dxa floor plan. Okay. And few projects like various smaller structures you have, you can take the help of the grid lines. So you may doing 5 projects from here. If you're doing 100 projects, then repeated structures you may do 2-3 projects. Okay, like that. IFC file you may get one project doing like that. This also architecture plan, one project like that. So if you're doing 100 of the projects, in that 80 of the project you will be doing through this step, which is very common, importing .dxa floor plan. It's very easy step of creating the mathematical model. So now you might be getting a very clear picture here that which step we have to learn it very well to create the mathematical model in ETABS. And this is very well like .dxa floor plan is very a good and reliable step and very easy step for creating the mathematical model in ETABS. Okay.
Yes, sir.
Okay.
Yeah.
Okay.
Any doubt? Anyone here? Okay. Very good. So let me proceed further, please.
Yes.
Yeah.
Yeah, sir. Please explain the wind again.
Okay. So when you are going to apply the wind load here, I told you that you can apply through the automated lateral load also. So when you go to define option in the load pattern, when you define the as a wind as a pattern here, and when you select the wind here, and when you select your auto lateral load code, that is IS 87 part 3 2015, when you add this, you may get an option of applying through the diaphragm extend and the cell object. So these two options you can select while applying the wind load. This is automated. This is very automated. You have to give it some few data here and automatically the wind load will get applied. But when it comes to the gust factor, in that case, auto lateral load will not work. Then you have to select the user load here and you can modify this lateral load. And can you see here that all the things will come here. So when you apply the diaphragm here, then automatically story will come, diaphragm will come, forces will come, and Fy, Fj, Mz values will come. And you have to apply manually here. Now you got it. So whenever you have to apply the gust factor, in that case, you have to apply through the user load. And when you have to apply through the codal provisions, like simply if you have to apply the wind load, and you can take the help of the diaphragm extend and cell object, which is automated. Okay, you don't need to give all the fx values and all. It will automatically calculate the fx values and it will get applied to that building. Okay, but in the case of the gust factor and all, you have to give it the user load, and through the user load, you have to give it all this data here, fx value, fy value, and mz value, and you have to apply. This will come through the story wise. Okay, and this will only appear when you will apply the diaphragm. So when the diaphragm will not apply, in that case, it will not work. Okay, so you have to apply diaphragm. In that case only, the wind load will be get applied. Okay. So I will open a model here to explain you more like what I mean to say here, what actually the diaphragm is. So actually this project, the diaphragm is applied. So when you go to define option and in the load pattern, when you will add a wind here, and when you select here as a user load, as a add new load, and when you modify this, now you can see that you will get a diaphragm here. So how much you want to apply at the OST level, terrace level, 6th floor, 5th floor, 4th, 3, 2, 1, ground floor, fx value, fy value, and mz value. So you have to calculate it in the Excel sheet, this all the value, and you have to apply this. Okay. So this is not automatically, you have to calculate it and apply it. But in the case of diaphragm extent, which step I just shown you while selecting your code, in that case it will be automatically applied, and you have to just give it some few data here, and you have to, it will get applied automatically. Like you have to fill like what is the basic wind speed, terrain categories, importance factor. These all basic data you have to give it, and in this you have to just give it like you have to apply it through the 90° and 0°. Also you have to give it the coefficient here, and it will get applied. Okay, and you have to select the story also, like top story which you want, bottom story. As you know that in the wind we don't apply it at the base. So if you have the basement, then don't select the bottom story as a basement. You have to select up from the ground floor. And if there is a parapet, then include parapet height also as a 1 meter. Okay, everyone clear here?
Yes, sir.
Hello. You clear now how what I mean to say here?
Yes, sir. Yes, sir.
Okay. Now, in the applying load, I already told you that we have a gravity load, which is a dead and live load. Earthquake load is your lateral load, which we can apply to the static and dynamic. Then we have wind load. Wind load also a static and dynamic, and the temperature loading also we can apply it. Now, this is the loading which you have to apply very, very precisely. Okay, so when you're applying the gravity loading, you have to like, why we are applying, like what is the calculations we are doing. So all the calculations of the gravity load has to be very accurately applied to the structures. Now randomly you don't need to like apply like 4 kilonewton, 5 kilonewton like that. If you're applying like that, it will get multiplied. Like if you're applying a 4 kilonewton load as a random to any floor, like I will, let me apply it. Like if the load was 2 kilonewton, but you have applied 4 kilonewton, let's suppose that. What is happening here, that when you apply to the floor, it will get multiply with all the floors here. And lastly, what is happening at the base, you will get it more load and foundation will heavier. Okay, so wisely and accurately you have to apply the gravity loading and all. Don't blindly apply it. Okay, anyhow, I will explain these all things, what actually how we have to apply this gravity loading and all. So means to say that you have to apply very accurately. Okay, so this all loading actually I will going to explain later on the workshop. Okay. Now next is your doing analysis. No, you have applied the structure loading. No, after applying the structure loading, we have to perform some analysis here. The analysis which you are going to perform is the modal analysis, first of all. Now, have you heard this name before, everyone? Please tell me, have you heard this name before, modal analysis?
Yes, sir.
No? Yeah, some people have heard this name. So,
Yes.
yeah. So what actually modal analysis is that, in this modal analysis, you get all the information of the structures. Okay, so let's suppose that if my structure is having 20 floor, 10 floor or 5 floor, so I will get a different time period of different floors here. Like 20 floor will have a time period of 2 seconds, 10 floor will have a time period of 1 second, and 5 floor will have a time of 0.5 second. So when your structures is having this much of the time period, it means that you have given enough mass and stiffness to the structure. Okay, so modal analysis is a complete information of the structures you're having, like what is the first mode, what is the second mode, what is the third mode. Okay, so anyone know that what actually code says about the first mode of the structure, first two mode?
Yes, we have to achieve the mass participation factor in first three modes in X and Z direction.
Right, how much it is?
65%.
Right, and what should be the first mode, second mode?
That is not written, just it is
No,
written that
it is
we have
written.
to
It is written. It is completely written.
90% of the mass
No.
participation
Yeah,
should
yeah,
be.
yeah. It is okay with that. But I will show you the code when the modal analysis chapter will come. Then I will show you
Okay.
that where it is written here. It will not completely written directly that the first two modes should be a translational mode. Okay, it will not
Okay.
written like that in your code.
Okay.
But in hidden language, it is written. Okay. So
In
when I will teach you the
2016,
modal analysis, which will
1893.
Yeah,
Okay, okay.
it is written. Okay, but I
Sure.
told you it is written hidden line. Okay.
Right.
So don't worry, I will explain you everything about the model analysis in that particularly that when we will take it the model analysis classes. In that I will explain
Sure.
you that where actually it is written, what is the mass participant ratio you have to keep it. So what the
Sure.
time period the structure should be there. So why I'm telling you the 20th story will have a 2 second of mass participant time period. Why I'm telling you? Because for achieving a very good structure strength, that is stiffness and mass, your structure time period should be multiplied with 0.1 multiply by number of structural floors. Okay. So if you are having a 20 floor, then 20 multiplied by 0.1 will come 2 seconds. So this formula you have to remember every time when you're doing model analysis. Like your time period, you know that TP is directly proportional to mass by stiffness, right? So when you're increasing mass in your structure, the time period will get increased. When you're increasing the stiffness in your structure, time period will get decreased. Okay, so there is a directly relation between time period with the mass and stiffness. Everyone knowing what actually time period it is? Everyone know, right? I have to explain this. Time period means that what is the structure time taking complete revolution. Suppose that if your structure is like this, and what time actually it is taking to complete one revolution here. So my structure is right like this. When earthquake will strike, my structure may go here, again come back to the original position, again can go to another position and come back to another position. This is the rest position, which we can say that the starting position. So what actually the time taken to complete one revolution here is your structure time period. Okay. So if your structure is taking too much time period to complete this one revolution, it means that your structure is not that much well stiffed. Okay. So a good structure will have optimum time period and optimum stiffness. Okay, so model analysis is gives you about your structure, stiffness, mass, and all data. How are you giving that? If your first mode is only having a rotational mode, it means that your structure is not well proportioned with the stiffness. Means you have given uneven stiffness to the structure. Okay, later on, okay, no problem. I think it will get bounced to you. I will explain this all things in this model analysis topic. Okay, don't worry. Okay. Now it comes to the earthquake analysis. So you have done the loading here, but you have to do the analysis of earthquake also. What is the lateral deflections limit? You have to keep it. Okay. What is the story drift? So these are all the things in the analysis will come. What is the base shear? What is the percentage of the base shear you're giving to the structure? Okay. So what is the minimum criteria you have to keep it while applying the base shear to the structures? Like how much percentage of the weight of the structures you have to apply as a lateral loading? So this all the analysis like about the earthquake has to be done in the earthquake analysis. What are the things I told you? A story deflection, a story drift, okay, base shear, okay. So you may also like you can do actually when you're doing actually the P delta and all through this, because this will come under the deflection, then P delta also will include in that earthquake analysis. Okay, so lot of important informations about the structures you will get it when you will do the earthquake analysis, like base shear. How much percentage of the base shear you're getting? Okay, so you may keep it maximum 10% of the weight of the structure. So this much of the percentage of the weight of the structure you can apply at the like maximum you can keep it, and minimum you can keep it 1 to 2%. So this little informations about the structure about applying the earthquake load, we will get it from earthquake analysis here. Okay, like same we have a wind analysis. In that also we have to keep it the what actually the maximum lateral deflection you're allowing. Then we have buckling analysis. Have you heard this name before, buckling analysis? Everyone, please answer me. Have you heard this name before? Buckling analysis? You may heard this before. No, actually, the buckling analysis we perform. This don't think that this is the column buckling. This is a structural buckling. Okay, so what is happening here? Due to the structures on structural configurations, a structure may get buckled. Okay, due to the structure on shape. Let's suppose that if you're building a circular structure. Okay, so due to this shape, the structure may experience some buckling load to that structure due to its own shape, I'm telling. Okay, so like that of the structures, we have to apply the buckling analysis or buckling load also. So a structure may get a load due to its own shape and configuration, and we have to calculate the buckling load, and we have to perform the buckling analysis also. So it will not get applied to the every structure. Few specified structures which is having a circular shape like that, a structure may get a buckling load. Don't think that this is the column buckling. The column buckling is different. This is a structure buckling I'm talking about. Okay. Then we have a construction sequence analysis. This I think you heard before, construction sequence analysis, right? No. So in this only you will get it creep analysis. So construction sequence analysis is like that. The structure is not made in one day. It is taking some time to build the structure, right? So if a structure is 25 floor and all, it may take 5 years of building time. Maybe take more than that also. So what is happening here? The time dependent property of the structure will come play. Okay, so the time dependent property of the structure will come in the play, and due to this, you may get additional forces here due to this. Okay, this is the construction sequence analysis. Okay, so when actually you are performing the analysis, you have to remember that we actually analyze our structure how from top to bottom, how the load is going to transfer from top of the floor to the bottom, right?
Right.
This is the way of transferring the load, right? Gravity loading. But how you're building the structure like this, right?
From bottom to top.
Okay, so this will come when you want to more accurate result and all, when you're doing some of the typical analysis, like we are doing the deep beam analysis and all, spandrel and all. In that case, the construction sequence analysis will give you a real result. Okay, because when you're doing the analysis here, you can easily see that we are going to give the load from top to bottom, but actually construction start from bottom to top. So due to this, you may vary a result here. But when you want to accurate this result, you have to perform the construction sequence analysis. This also is not to do for every structure. The structure which will have the floating columns, deep beam, spandrel designs and all. Okay, tall structures and all. In that case, you may perform this construction sequence analysis.
What is
Okay.
what did you just say? Spandrel design? Spandrel?
A spandrel is actually the deep beam. Okay, you may call it a spandrel deep beam. Yes. When you are modeling a beam as a 2D element. Yeah, let me clear here.
See a beam or deep beam?
Deep beam, when you're going to give the floating columns and all, in that case, where the beam column will get rested. So actually, when you're giving a floating columns, okay, like
Floating
this.
column means from
it will from base. It will not be their column. The construction of the columns will start from the beam only. Okay.
Okay.
So in this case, where will be deep beam will come. In that case, you have to give it as a spandrel. A spandrel, actually, when you're modeling a beam as a 2D element, right now you can see a beam here. This is the 1D element only.
Right.
Okay, one dimension of the element you can see here that. The same thing when we will model as a 2D element, we will call it as a spandrel. Okay, but when to model 2D element, when there is a deep beam and all, because when in the deep beam, what is happening here,